Now the graphing continues to be a source of consternation for my students, but let's go ahead and just work through some graphs together, okay? All right, so very first one, a constant velocity with a positive slope moving away from the origin. Okay, so a constant velocity, I got pretty much the whole thing, so constant v, positive slope. Oh, okay, I'm sorry, I got that backwards. Hi, Chris, and the Mexican kid is Gerardo. Chris, are you one of my students too? All right, let's just go ahead and do all of these real quick. Okay, so, hey, how you doing, Skylar? Welcome back. Okay, do you go to Jersey Village, or are you from a different school? Well, either way, let's keep going. So, I have a constant velocity with a positive slope. So, constant velocity, positive slope will look like that. We have our x on the side and t on the bottom. Now, since we have a positive slope, that means we're going to have a positive velocity. And it says a constant velocity, so a constant positive velocity. Again, right there. And because it is a constant velocity, our acceleration is 0. So, thick line right there at 0. Pretty straightforward. And this follows a pretty straightforward pattern. We normally, well, that is to say almost always, see our slopes, our graphs get straighter and straighter as things go on. So the pattern that I like to tell my kids is, can you see it right there? Curved, straight, flat, 0. Curved, straight, flat, 0. That is the order in which your graphs will follow. They will get less and less curved as the whole thing goes on. Okay? I apologize for all the yard work noise, but this was the only time I had to do the thing. But either way, let's keep going. Okay, and we can see that pattern in these three graphs right here. We have a straight line with a slope, we have a flat line with no slope, and then we have a 0 line. So let's do the next one. The next one is a constant velocity with a negative slope. Constant v, negative slope. Okay? So we don't actually have to be in the negative side of the position versus time graph for this. We can still have a negative slope like that. Now, because of that, you'll notice the way I drew this, that this is the negative side of a graph, and here we have a constant negative velocity again. And because this one is straight, this one is flat, that means our acceleration graph is again a big fat 0. Big fat 0 right there. Cool. And again, we can see the pattern continuing. Curved, which we don't have any curved, but then straight, flat, 0. Okay, a faster changing velocity moving away. So let's say change v, faster, and positive because it's moving away. So since the velocity is changing, oh, okay, good. Since it is changing but getting faster, what we're going to see is the slope on this get more and more positive, or steeper and steeper. So boom, like that. Okay, that's our x versus t graph. And now, because this one is curved, we would expect this one to be straight. And because it is getting more positive, since it's getting steeper and steeper, we know our velocity is going up. Boom, right there, curved, straight. And our acceleration graph, which is just the slope of this line right here, since it's positive, our acceleration would again be positive. And we can see our pattern that we were concerned with before. Again, curve, straight, flat. And if there was a fourth one over here, that one would be 0. Curve, straight, flat, 0. Curve, straight, flat, 0. Over and over and over again. So take a look at this, and then we'll go ahead and do the next 3. Woo! Up to 7. Is it my birthday? How's everybody doing out there? Everybody getting a lot of good information from this? A lot of people think Tuesday is the worst day of the week. But I think it's okay. We've already picked up 2 followers today. This is a fantastic one. I've been stuck on well, 3 followers. I've been stuck on just below 70 for over a week. All right. So, let's move on. Okay, so let's do the next 3. All right, next 3. Faster changing velocity moving towards origin, slower changing velocity moving away, and slower changing velocity moving forward. Okay, so number 4. Faster v towards the 0. Okay, so let's go ahead and look. So faster towards the origin. Again, so our origin is down here at this 0, right? X, and then our t. Now, to get faster, the slope of our line on a position versus time graph has to get bigger. Okay, so it has to get more and more steep. Now, the way that's going to look on a position versus time graph is you're going to be flatter at the top and then steeper and steeper as it goes down, right? You can imagine that if you were like riding down that hill, it would get faster. You would accelerate as you went down. Now, because the slopes on these are all negative, that means our velocity will be negative the whole way around. But because this line is curved, this line is going to be straight and have a slope, again, negative slope because it's pointed down and to the right. Boom, right there. Now, my drawing isn't terribly good, but that is supposed to be a straight line. Okay? And again, curve straight, so that means this one is flat. This one has a negative slope, which means our acceleration will be negative. Boom, there we go. Okay? It doesn't actually matter what these numbers are, okay? Because right now all we're concerned with is trying to nail down the analysis of these kinds of graphs. Okay? Okay. All right. Number 4, or number 5, number 4. Slower changing velocity moving away. Okay? So, slower v away. Because this one is changing still, it's going to be curved, all right? But since it is getting slower, the slope is actually going to flatten out. It's actually going to, not get steeper. So what we have is steeper and then flattens out. Boom, like that, okay? X and t, again, are 0. And you can see we're still getting further and further away from our origin. It's just we're moving slower as we do. Now, because all of these slopes are still positive, we have a, okay, so, okay, so, yeah. There we go. Because it's getting closer and closer to 0, our velocity versus time graph is going to move towards 0. Even though we have a positive slope over here, Chica Games, are you in this? Are you here in this chat? I'm unfamiliar with you. Say hello. Anyway, so these positive slopes the whole way around means that our velocity has a positive value. So right here, where the slope is the biggest, we have the biggest velocity value. And then as it gets closer and closer to 0, so does our velocity. It gets closer and closer to 0. But, again, just like up here, we have a negative slope on our velocity versus time graph. And so that means our acceleration versus time will have a negative flat. Again, curve, straight, flat. Curve, straight, flat, 0. Curve, straight, flat, 0, over and over and over again. So that's what we are looking for. Okay, now let's see if I can fit one last one on here. So slower changing velocity moving towards. Slower v towards. All right, so slower v towards. There we go. Okay, now again, we are going to be moving towards the origin, just like it says, but we're going to be flattening out as we get closer and closer to the origin. That's going to be more or less the exact flip of this one, and steep, and then it bottoms out towards the bottom there. Okay, x, t. Again, this is curved, so this one's going to be straight. Now, all of these slopes are negative, which means that all of our velocities will be negative, but getting closer to the 0. So that means our most negative one is here at the beginning, and that it goes up to 0. So from negative velocity up to a 0 velocity, or up to a stop. So we sort of plane out right there and stop. But unlike these two, we have a positive slope on this guy right here. Our acceleration, oh, I did that one upside down. We have a positive slope on our acceleration versus time graph, so we can draw it back the regular way. Acceleration time, and a positive. So again, we have curve, straight, flat, and if we had one more over here, it'd be 0. Curve, straight, flat, curve, straight, flat. Okay, so you can see that pattern is always followed. There are exactly 2 situations in which it would not go curve, straight, flat, 0. One of them is an exponential function that you won't see in your Physics 1 courses, and the other is if these were all 0. If it was 0, 0, 0, 0, 0, 0, they would all be 0. But since it's not, it goes curve, straight, flat, 0. Curve, straight, flat, 0. So if this one is curved, straight, flat, 0. Now if this one were straight, it'd be flat, 0. And if this one were flat, it'd be 0, 0, 0, 0 from then on. Okay?